Hello everyone. In this video, we'll be solving problem 455, assign cookies. The problem statement is, we are given two arrays, G and S. G represents the kid's greed factor or appetite, and S represents the size of the cookie. We need to return the maximum number of children whose appetite can be content with the cookies that are given to us. In example number 1, we have 3 kids with appetite 1, 2 and 3 and 2 cookies with size 1. With these as our input, we can only content one kid whose appetite is 1. Hence, the output is 1. While in example number 2, we have 2 kids with appetite 1 and 2, and we have 3 cookies of size 1, 2 and 3. So we can easily fill the appetite of both of the kids by giving them or assigning them these 2 cookies, and we'll be left with one cookie with size 3. I hope you were able to understand the problem statement. This is a very easy problem. So let's switch to whiteboard and discuss how we can solve this problem efficiently. Let's use this as an example. To be able to assign the right cookie to the correct kid so that they are content, we need to make sure that the input is sorted. Else, we may end up assigning a cookie of size 3 to a kid whose appetite or greed factor is 1, which may not be efficient. The examples that we were looking earlier were all sorted, so it was easy for us to visualize and assign the cookies to the kids to make sure that their appetite is matching without concerning ourselves if it is an efficient solution or not. And it was only possible because the input arrays were sorted. But what if the input arrays are not sorted, like in this example? If we start assigning, 3 will be handed over to the kid whose greed factor is 2, which is not efficient. If we had a kid with appetite 3, we won't be able to content because 3 is already assigned to the kid whose content or greed factor is 2. The same could be said if we assign the cookie size 2 to a kid whose greed factor is 1. This is not efficient and we may not be able to content maximum number of children. So to be able to cater to maximum number of children, we need to first sort the input arrays and make sure they are in ascending order before running the loop and comparing the cookie size with the children's greed factor. Let's run a small simulation by sorting the input array and then running a loop to compare the size of the cookie against the children's greed factor. Now that the arrays are sorted, we will use two pointers approach, one pointing to each of the arrays and compare the corresponding values. To meet child's greed factor, S of j, that is the cookie size, should be greater than or equal to the child's greed factor, that is g of I. If the condition is satisfied, we can use a separate counter, let's call it content, and increment it every time. The child pointer will be incremented if we are able to content the child's greed factor, and the cookie counter will be incremented every time during the loop. We'll run this loop until all of the children are content or the greed factors are met or there are no more cookies left to be served. Once either of the conditions are not met, we will stop the loop and return the content as our output. With this solution, our time complexity is O of n log n plus m log m plus O of m plus n. It is because we are first sorting both of the arrays G and S. So n log n and m log n represents the time complexity for sorting, and O of m plus n represents the time complexity for running two pointers on both of the arrays. This can further be simplified as the time complexity being O of n log n plus O of m log n. And the space complexity is O of 1, as we are using two pointers and the content counter to record the total number of children whose greed counter were met. I hope you are able to understand the explanation. Let me show you how we can implement this using Python. In the Java implementation, I start by sorting the input arrays in ascending order and then start a while loop to compare the child to the cookies available to us. Inside the while loop, I'm comparing if the greed of the child at the child pointer is it less than or equal to the size of the cookie pointed by the cookie pointer. If yes, then we increment the count by 1 and also increment the child pointer so that we can look at the next child. And irrespective of the condition being met or not, we will increment the cookie pointer every time. Once the while loop is complete, I'm returning the count as our output. This code, when submitted on LeetCode, beats 91% of the submissions in terms of runtime and nearly 30% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.